Hi everyone, I'm back with another video. Today I'll be talking about Six Sigma. Six Sigma is a method that provides techniques and tools to improve the capability of processes. Efforts are made to achieve stable and predictable results by reducing process variation. Implementation of Six Sigma strategies lead to defect reduction, increase in profits, improvement in customer satisfaction, and quality of services or products. The Six Sigma experts use tools such as statistical process control, control charts, process mapping, and failure mode and effects analysis to drive process improvement. Six Sigma projects use two methodologies. DMAC, which stands for Define, Measure, Analyze, Improve, and Control. DMAC approach is used to improve an existing process. DMAD-V, which stands for Define, Measure, Analyze, Design, and Verify. DMAD-V approach aims to create new product or process design. Normal distribution or bell curve is the most commonly used statistical distribution in Six Sigma. This distribution demonstrates that the data points around its mean or average are more frequent in occurrence than the data far away from the mean. In this distribution, about 68% of the data would fall within 1 sigma or standard deviation from the mean. For those who do not know what standard deviation is, it measures the dispersion of data points in relation to their mean. Now looking at the graph below, you will see about 95% of the data would fall within 2 sigma or 2 standard deviation from the mean. About 99.7% of the process data points would fall within 3 sigma or 3 standard deviation from the mean. Dr. W. A. Schuhart developed quality control chart which provides a view of the process performance metric over time. Data points are plotted on the chart. The center line indicates the average or mean of the data in the chart. 3 sigma or 3 standard deviations above the mean are used to set the upper control limit. 3 sigma or 3 standard deviations below the mean are used to set the lower control limit. The quality control chart represents the values of the observation of the process. The distance between upper control limit and lower control limit is 6 standard deviations. The process is considered to be in statistical control when it is stable, consistent, and predictable. In the graph below, the data points that are within 3 sigma above the mean and within 3 sigma below the mean constitute approximately 99.7% of the data points, and they are within the control limits. The remaining 0.3% of the data is beyond the 3 sigma lines. 0.15% of 0.3% data lies above the upper control limit and 0.15% below the lower control limit. Sometimes an adjustment of 1.5 sigma is applied as variation increases with years of process and data collection. Accounting for a 1.5 sigma shift in the mean, Six Sigma performance means that there are 3.4 defects per million opportunities. Quality control charts also indicate whether the variation is common cause or special cause. Now, what is common cause variation? This variation is inherent in the stable process or system. It is also known as normal or random variation. A random variation can be caused by the design of the process, normal wear and tear, training, selection of equipment, etc. With common cause variation, all data points fall within the control limits and show no special patterns or runs. Special cause variation is caused by new unanticipated phenomena within the system or process. This variation indicates an inherent change in the system or process. Some examples of special causes are human error, equipment malfunction, long lab test turnover time due to a new software. Special cause variation is indicated when a data point or data points fall outside the control limits, or when data is within the control limits, it shows trends or special patterns. Healthcare managers and or process improvement leaders monitor process and outcome measures in order to understand and reduce variation in patient populations. They manage variation over time by utilizing real-time data. They reinforce desired variation and reduce undesired variation by comparing present, past, and desired performance. Six Sigma certifications. There are three types of Six Sigma certifications: Certified Six Sigma Black Belt, Certified Six Sigma Green Belt, Certified Six Sigma Yellow Belt. Now, the Black Belt professionals have a thorough understanding of the DMAC model and Six Sigma principles. The Certified Six Sigma Green Belt professional works under the supervision or in support of a Six Sigma Black Belt and contributes toward quality improvement objectives. The Certified Six Sigma Yellow Belt is for those who have a small interest or wants to gain knowledge of its fundamentals. Here you will find the references to the material that was used to create the content of this presentation. If you like this video, please subscribe to my channel down below. Thank you for stopping by. See you next time.